All right. Can everyone hear me? Perfect. Welcome to United Astronomy Clubs of New Jersey. We're once again back in time for a lovely presentation tonight. First things first, while I let a couple people file back down here from looking at all sorts of fun things, do check us out on our website, uacnj.org. That's where you're going to find a whole bunch of information about who we are as a nonprofit organization, what we do, which is try and connect people with their local astronomy clubs and bring the joy of the hobby to everyone we can, as well as educate on various science topics. And it's also where you can find a list of our talks, past, present, and future, as well as information on our member clubs. In addition, you can check us out on our social media pages. We have Facebook, Instagram, Twitter. We have a Discord server. So if you have any burning questions or want to share your astrophotography, there's a place to do it. Do tag us in those things. Do like and subscribe on our YouTube and Twitch pages because we do live broadcast these programs. So if you ever can't make it up here, or for our viewers who are joining us from all sorts of parts of the world, we do welcome you. And like I said, do hit that like and subscribe to get notifications when we are live. That being said, tonight's presentation, I need to do a safety brief first before we get into it. For those of you who are here, when we go to leave, we are using our headlights because we do not like being run over, and I'm sure you agree with that sentiment. We would all do with a little less vehicular assault in the world. So, headlights, we are using them. Flashlights, we will keep them pointed down towards the ground so we don't accidentally blind people with bright lights in the eyes, because night vision is a precious thing and it does get lost when we do experience light. That being said, I will mostly be night blind because I'm going to be staring at a screen. So I'll lose it. So when we come to the Q&A session, for the people here, you're going to raise your hand and wave it about because I won't be able to see you when it's dark. All right. Second thing, if you need to use the bathroom, it is the porta potty in the back to my left, so that's your right. In addition, you can also check out our gift shop and museum area after the talk. With that, our talk is Life Beyond Earth with Karl Hricko. Sorry, my voice just cracked because allergies are no fun, and we are in a state with lots of trees. Karl received a doctorate degree in Science and Humanities from Rutgers University and was Science Department Chair and taught Earth Science and Biology at Carteret. He's been past president of astronomy clubs and continues to conduct science programs on WNTI and make presentation on science topics. He began a National Space Society chapter in New Jersey and became a space ambassador for NSS. He has used the Hubble Space Telescope and currently has a podcast called Karl's Orbit. And with that, Karl.
I'm trying. There we go. Now we go. Okay. Welcome, everybody, to United Astronomy Clubs of New Jersey at Jenny Jump Forest. Glad to see that you're here. And I'm sure you're here because you have an interest in something involving astronomy, I would assume. Hopefully, it'll clear up nicely later on so you can view some of the beautiful celestial kind of objects in the sky. But in the meantime, talking about what's beyond the Earth, do we know if there's any kind of life existing beyond our planet? Interesting kind of question. Nothing tangible yet, but all kinds of tantalizing sort of clues that there might be something there. Let's go on here. Life beyond the Earth. Now, a little bit of a commercial to continue. I also belong to the National Space Society. We have a chapter in New Jersey, and if you're interested in joining, see me after the presentation, and I'll collect your money. No, we have no fees, no dues, nothing. It's a chapter representing National Space Society, and you can see how to access the NSS if you want to see what it's all about by going to www.nss.org. And we also have, oh, okay, we also have our logo in terms of our chapter of the NSS, which is the Space and Astronomy Society of NW, Northwest Jersey. Now, in order to get into the area involving life existing elsewhere, we have to know some information, some background information. And the study of that area involves astronomy and biology. So you put the two together and you have astrobiology as a result, which is the study of living things found throughout the whole universe, including the Earth. There's also another branch, exobiology, which is the study of living things that exist, we'll say, everything outside of the Earth, exobiology. And I'll be coming to this later, but you know, they found 5,000 extrasolar, or now they're calling them exoplanets, outside of our own system. Can you imagine that? 5,000 of them. And of the 5,000, they found about 55 that appear to be Earth-like. So there's a good chance that there might be some life out there after all. But nothing really concrete so far. Now, life in space? Well, I don't know about this mouse, but Mickey Mouse is looking for Pluto, I guess. He's in space somewhere. Background, though. Way back in the 4th century BC, Metrodorus, a Greek philosopher, thought about there being other worlds out there by saying, of course, as you see here, it would be strange if a single ear of wheat would grow in a large plain, or that there would be only a single world, ours. So he was saying there was much more in the way of worlds out there. 4th century BC. Quite interesting. Now, suppose we receive some kind of object from space. We captured some object. And these are samples of objects that were captured, by the way, from space, coming in, of course, through our atmosphere. How would you know whether or not they're living? It would seem that you'd have to have some kind of criteria to determine whether or not they're living by comparing them to things on Earth, because there's nothing else we have to go by other than what we see on Earth and ourselves. Now, the chemical basis of life is based on carbon. We're leaving carbon footprints all over the place. I don't know. Get rid of carbon, get rid of us as well, I suppose, because our structure is basically carbon. Makes up almost all of our chemicals in our body. And it works in water. We have to have water because we were made of around 60% water. So water is necessary as well in terms of chemistry of life. Now, there is a possibility of substituting something for water in the way of substituting, for example, on the left it would be something like ammonia, NH2, or something like methane, CH4, in a liquid form, though. In order to do that, you'd have to freeze it. And that kind of reduces the chemical reaction rates, slows it down considerably. And so they wouldn't be a very good substitute, but it might very well be on some of these exoplanets. This does exist, and we might find some kind of extreme life forms living in those areas as a result. Now, carbon has 4 electrons which are not paired in its outer ring. And as a result, it can combine with 4 other atoms, making it a very versatile kind of atom, which is why probably it's the basis of our life here on Earth. And you can see it forms long chains of various kinds of molecules as a result of that, in order to produce upper left proteins and, carbohydrates, lower left proteins, upper right lipids or fats, and lower right it would be something in the form of nucleic acids, DNA and RNA, carbon necessary for each one of these complex molecules. Now, in order to go on with the notion of how do you know whether or not an object comes from space that is alive? Well, you have to set up a criteria involving properties of life. And different kind of textbooks in other areas give a different, not a different, but maybe more expansive list. But here it shows the basics in terms of all life seems to be organized in some fashion, otherwise it can't function efficiently and effectively. And so we have life showing us order or some kind of organization. We also have a need for energy. That's why we eat the food we have, because the energy is transferred from the sun to plants, to animals, to us, or directly from plants to us. Energy from the sun is necessary. And so energy is required as well. We also have the idea of life being able to reproduce, having to reproduce, otherwise there's no next generation. So there has to be reproduction of some sort taking place. And there's got to be some kind of response to the environment. So there's protection against various kinds of environments that's detrimental to life. And the idea also is adaptation and evolution of life changes as time goes on. And mutations are involved in that kind of process, where most mutations are not good, not advantageous, but other mutations are. And so those lead life on to produce better kinds of species. Now, there's got to be some form of information that's stored somewhere to be passed on from generation to generation in living things. And again, we're talking about the properties of life to a certain extent. We're talking about what's necessary as a criteria for determining life. And that information is stored in a structure, as you probably know already, called DNA, and in viruses in RNA. In a double helix in DNA, by the way, deoxyribonucleic acid, RNA, ribonucleic acid. So it's stored in the spiral kind of a molecule. Now, how it's stored is inside of a chromosome, which is inside of a cell. So if there's to be any kind of transfer of this information onto other forms, next generation, there's got to be a way of growing first. And so the first type of cell division I want to talk about is, not very much, mitosis, which means that one cell divides and makes two. In the meantime, when the cell is dividing inside of it, the DNA is dividing, the nucleus is dividing, the chromosomes are dividing, the cell is dividing. They're all dividing into forming two cells, forming growth, regeneration in our bodies. But how do you pass on the information to the next generation? Well, you go into another form of cell division, which involves something called meiosis. Two cell divisions. In the first cell division, you form two cells. You only separate the like chromosomes. In the second division, you separate those like chromosomes into the strands that make them up, the chromatids. So the result is, at the end, you're producing 4 cells in the reproductive organ. Now these 4 cells have a variation of different kinds of chromosomes, which combine with the corollary type of reproductive cell in the form of an egg, sperm, egg. But this is how that process takes place in a reproductive organ in order to pass on all our characteristics to the next generation. Meiosis is required. To keep us alive to do so, mitosis is required. So these are the forms of processes in which the information is transferred, necessary. And it's enclosed within a kind of a sac-like structure called a cell. A cell is the building block of all living things, making tissue, organs, organ systems, the organism. 2 basic types of cells. On the left would be animal cell, on the right would be a plant cell. Plant cell varies in difference mostly by the fact that it has a cell wall, where animal cell doesn't, because animal cell is part of a structure which has a skeleton, whereas in a plant cell, no skeleton. So we have to have some rigid structure to hold that structure, and the cell wall does that in each individual cell. Other kinds of structures inside the cell are for the purpose of energy, for the purpose of passing on the information in terms of those chromosomes and the nucleus, and so on. But these sacs will hold that information. Now, there are certain kinds of requirements for life, and those requirements have to do with there being liquid water. Got to have liquid water, because we're made up of around 60% water, as I mentioned. Water in which chemical reactions take place, in which transfer of all kinds of chemicals take place within the body. So water is necessary, liquid water. Now, also what's necessary, of course, is the atmosphere. We get oxygen. That's necessary. Also for controlling vaporization, the elimination of water from our cells, because if there's water in the air, less water leaves us. That controls the vaporization process. We don't dry out. So we need the atmosphere for that purpose. Also in the environment, we do need a kind of controlled temperature, a moderate temperature range. And that applies to other things in the environment as well, as we'll get into very shortly. But right now we're talking about the temperature range that we can exist in. That temperature range has got to be present in those planets going around those stars in which we expect there to be some kind of life. And then, of course, we have the idea of this idea of temperature controlling complex chemical reactions. And time. Need time for things to develop. So far, it's been about, what, 4.7 billion years, something of that nature, since the beginning of our galaxy. Okay. Now, if the environment is extreme, we have to have organisms that can exist in this extreme environment in order to maintain their performance. And so to do that, these organisms have to adapt. And when they adapt by having genetic diversity, where there's mutations occurring. That provides diversity. In some cases it's bad, in some cases it's good, but that diversity is necessary. And that leads to metabolic diversity as well, in terms of the chemical reactions going on, being diverse. So what kind of organisms can exist in this kind of a situation that have all this diversity? They're called extremophiles, living in these areas, these environments that have wide ranges beyond what we ordinarily can exist in. They're called extremophiles as a result of that. And here's some examples of some extremophiles living in areas where there might be a wide variation of temperature, a wide variation of pressure, a wide variation of salt, salinity, a wide variation of pH in the form of, let's say, alkaline versus acid conditions, wide varieties that we could never exist in, but these extremophiles do. And so it's possible that we can find these extremophiles living on other planets elsewhere, the exoplanets themselves. That's a possibility. We never really knew that these extremophiles do exist, but now we do. And so it opens up the possibility of a lot more kinds of organisms possibly existing on various exoplanets. Here's an example of deep sea hydrothermal kind of vents in which organisms live around where the temperature is quite high, and also they don't have free oxygen. It's bound up in a molecule involving sulfur, like sulfur dioxide or something of that nature. And so they're able to live under those circumstances. And these might be the circumstances in the environments existing in those exoplanets. Who knows? So all kinds of extremophiles living in extreme environments. Diversity is important, biodiversity. We have that on Earth. We expect the same to exist on other planets as well. Now, what about life in the solar system besides the Earth? And here's all the planets except, where's Pluto? I don't see Pluto. What happened to Pluto? Gee, I don't know. I like Pluto as a planet yet. Sorry, folks, but anyone like Pluto yet as a planet? I don't know. Okay. Well, you're on my side, huh? Okay. Anyway, we get into the planets. Does life exist on the planets? Well, not too likely on the gas giants like Jupiter, Saturn, Uranus, and Neptune. Pluto's too far out, too cold, away from the sun. Chances are it doesn't, even in the way of extremophiles. But on Mercury, no, too close to the sun. Although now they found, by the way, just let me go back to the oops. Yeah, on Mercury, they found some areas of frozen water in hidden craters on Mercury, the closest planet to the sun, and you would never expect that. This was found out by the probe they sent out there called Messenger. Came up with that information, which is brand new information about Mercury. As brand new as possible, anyway. But although the outer giants, Jupiter, Saturn, Uranus, and Neptune, may not contain life on the planets themselves, their moons might contain the life. That's where we'll be looking. Oh, let me go back. Now, there is a possibility of another molecule substituting for carbon. You probably heard, or if not, you'll be hearing about silicon. Carbon has 4 atoms in its second outer shell that can bond with other electrons on other atoms, making it very versatile. That's why we have it as the basis of life here on Earth. Silicon also has 4 electrons unpaired in its outer shell, but it has 3 shells, whereas carbon only has that 2 shells. And so it's more versatile. It has a quicker chemical reaction. It bonds more quickly. It's more versatile than silicon. But that doesn't rule out silicon as a possibility of the basis of life elsewhere. Now, what about life here on Mars? Well, any Martians there? Well, not like this anyway, I'm sure. Oh, by the way, Mars has always been something that has been looked upon as being a mystery, and always some kind of life form were in the minds of people who thought about Mars and saw Mars. And as a result, you have all kinds of movies, comic books came out about Mars, about living things on Mars. So the mystery was being attacked by various kinds of artists and performers in movies and things of that nature. But usually they were malevolent. They were attacking the Earth, and so on and so forth. To make it interesting in the movies, I guess that's what they did. Now, here's something interesting. Can you see something here? Don't know if any of you have come across this image. What does that look like? A possible face on Mars. Yeah, Viking probe went by, took some images. They looked at the photos, and someone said, wow, look at that. It looks like a face on Mars. Wait a minute. How could that be possible? And then, of course, they come up with all kinds of conspiratorial kind of notions, like, well, maybe it's a monument left over by an ancient civilization that could have existed on Mars. So they got closer, looked at it again, and the brain works in funny ways. It likes to make sense out of things that we see, even though it's not what we see, unfortunately, and it creates illusions for us. And so we still see a face. But then NASA said, wait a minute, let's take some better images. Let's fly by another probe, take some more images, and see if it changes. And they did. It did change. It's a plateau of some kind of geological feature on Mars. So you can see how the brain works in fooling you into thinking that something is there when it's not. Now, looking at Mars, something interesting, there's large-scale information about water on Mars. You may have heard about this as well, where at first they came across information about water in the atmosphere. So we have fog in the atmosphere. We have the idea of frost on the ground. We have areas where it's glaciation, and we have areas where there's ice in the polar regions. But they haven't found flowing water yet. Although I'll go on, and there's some suspicion that they might have, the Chinese may have, in the probe they sent up there recently. And I'll get to that later. But in the meantime, this would be the first ideas about there being water on Mars. And of course, if there's water, the next step is to think, well, maybe if there's water, there might be some life, or there could have been some life in the past. And this is the idea involving this idea of large-scale indications. Also, there's these gullies that are formed by water ordinarily on Earth. We see them on Mars, and they pop up every so often. So it seems that water has a hard time existing on the surface, unless it's salty water, because of the fact it vaporizes quickly. And so as soon as water comes on the surface of Mars, bam, it vaporizes into the atmosphere, but leaves behind these gullies, it would seem. So this is an idea also about these large-scale. There's also small-scale structures, certain kinds of rock formations like hematite, mineral hematite, or the rock hematite, also considered a mineral, I suppose, because it has mostly iron in it. And Mars seems to have a lot of hematite, which is a rock structure produced by the remnants of living things. It provides what's necessary for the formation of hematite. Also, there's some kind of marble-like structures produced that look blue, and so they call them blueberry type of rocks, which are the result of biochemical reactions. But also, I suppose, by other kind of reactions too, but not ruling out the biochemical reactions. So they're still there as possible kinds of evidences of life existing or having priorly existed on Mars. Also, sedimentation of rock, sedimentary rock that on Earth only formed by water. So these will be examples of various kinds of small evidence or scale structures of life on Mars. And it goes on to form out other clues that are found on Mars. Like, for example, they found methane gas in certain areas of Mars on the lower right. Those are the areas where they found localized on Mars. And it seems that methane is produced by living things, also by other processes which are not living, but by living things as well. They're localized and they're being replenished because they degrade in about 3,000, or rather 300 years. They degrade. And so we still see methane, traces of methane. So this raises the question about whether there's life as well. And also the existence of various kinds of caves which are produced by water motion, wearing out the rock structure producing the caves. So methane and caves seem to be the idea of this in space. Now, this is something whoop, I went too far. This is something interesting. Yeah, one more. Yeah, that's it. This is interesting. It's a repeat of the picture you saw before. No, it isn't actually. It's an image of a rock, ALH rock, that came from Mars, a meteorite. They sliced open the meteorite, looked at it with an electron microscope, found some very tiny nanobacteria in it, which resemble the nanobacteria found on Earth here. I believe it's under the Pacific Ocean. We have these types of nanobacteria, or it appears to be this type. But when this was found and examined with an electron microscope, the team that examined this came to the conclusion that this, not a conclusion, but maybe an interpretation of it, this might be evidence of fossil life on Mars in the form of these nanobacteria. And that's what these things seem to represent. Now, no one has replicated this kind of research yet, and this is the problem. No one has replicated it. You have to replicate it in order for it to be accepted as a valid kind of a finding. And so we're still waiting. Now, on the other hand, the cartoon showing if there were living rocks on Mars, they would be saying, I wonder if there's any rocks on Earth. Just like we're saying, I wonder if there's any life on Mars. Now, what about other areas of the solar system? Well, if we look at Jupiter, and we look at the 4 major moons of Jupiter discovered by Galileo, by the way, in about the 1400s, a long time ago, named after him, the Galilean moons. You'll see this, by the way, on a clear night here, through a telescope. You can see the 4 moons that Galileo saw. And we'll see them right now, as a matter of fact, but on the screen, not up in the sky. And this is the closest one, called Io. Too hot to have life, unless it's really an extreme O-file. This one, interesting, Europa. It has an ice covering over the crust. You can see the cracks in the ice. Below it might be an ocean. That's what is expected. And NASA has prepared a program to send out a probe to crack through the ice eventually, when they get more money, I guess, to find out if there's anything existing below the ice layer. That's quite interesting, I thought. Here's a diagram showing you Europa broken open with the crust and the water layer underneath it, an ocean. Interesting. The next one would be Well, this is the next one, but this will be an example of maybe some of the organisms that you might find below the ocean. Somebody's fanciful imagination, I would imagine, to a certain extent, but it might be true. Who knows? Next one is Ganymede, the largest moon of Jupiter. Same thing. Next is Callisto. Same thing. Ice on the surface. Water beneath. Comparison of all four. Upper left would start with Io. Upper right, Europa. Lower left, Ganymede, the largest one. And lower right, C. Callisto. You can make a phrase out of it. I enjoy good coffee. Io, Europa, Ganymede, Callisto. That's how you remember it. What about Saturn? Well, Saturn seems to have two candidates. On the upper right, the second one down would be the largest moon, Titan, of Saturn. And the other one would be the second one from the left. That would be Enceladus. Enchiladas, I don't know. Enceladus. And Titan is interesting. Titan is looked upon as being a possible kind of former Earth type structure. It has mostly nitrogen in its atmosphere at this time and some methane. And as a result, it has lakes and rivers of these hydrocarbons flowing on the surface. Weird, not water, but methane and nitrogen in a frozen form. Substitutes for water. There you go. Maybe on Titan. This might be the example of that substituting the liquid methane for water on the surface of Titan. Enceladus, another one. It has these gushers of water flowing out of the surface. Ice droplets from the South Pole of Enceladus. Interesting. Water again, necessary for life. All tantalizing kind of clues, but nothing really concrete so far. That's the frustration. So, in an artist's conception, this is how you might see Saturn if you were on Enceladus, for example. Now, what about other life in the universe? How about our Milky Way? There's a lot of stars in the Milky Way, billions of stars in our Milky Way. And, by the way, each star is thought to have at least one planet going around it. So we're talking billions and billions of possible planets. Now, we're only looking at the exoplanets that exist in our areas of the Milky Way. And in the Milky Way, this is artist's conception of top or bottom view, upper. Lower would be the side view like a plate. We're located in one of the spiral arms in the outskirts, in the suburbs of our own galaxy, which is how it would look here if you were an alien coming in looking at the top of or the bottom of our galaxy, the Milky Way. That's how it would look. So we're pretty safe away from the supermassive black hole that happens to be in the center of our galaxy, by the way, Milky Way galaxy. If you look in the area of the constellation Sagittarius, that's where the center of our galaxy is, and that supermassive black hole. So if you ever get a chance to look through our telescopes, find Sagittarius when it's visible in the sky. Usually it's like late fall, early winter, that kind of time. Now, astronomers consider there to be life zones around stars, certain areas where planets exist that don't have life. It's the wrong name. It's called ecozone as well, and it's also called habitable zones, or potentially habitable zones should be a better way of phrasing it, or potential life zones, because it's the zones where water can flow as a liquid. That's what the life zone means, actually. And so you can see the second one to the right would be something like our star, a G star, that has a good expansive life zone in which the Earth, Mars, and Venus happen to be located. If the star is too large, it has a short lifespan, not long enough for life to take place, involving however it takes place. Here's our star, a G2 star, the Sun. Now, there are these extrasolar, or now called exoplanets for short, that have been discovered. I mentioned about 500 of them so far. That's only in our area of the galaxy, in our suburb area of the galaxy. Now, there's been about, I said, about 55 of planets that resemble the Earth, Earth-like, which might be habitable. No one knows yet. But this information is being found out. Now, anyone spot any of these things in the sky so far? Anybody? Anybody been abducted? Nobody abducted either? Oh, okay. I was abducted, but by my family. That's it. Well, speaking about that, life existing elsewhere, uh, this guy, Frank Drake, came up with an equation to figure out the probability of how much life can exist in our Milky Way galaxy. How much life can exist, and maybe is existing right now. So he came up with an equation, which is a kind of rule of thumb equation. It's not that precise because a lot of information is not known yet fully. But what information is known is used in the equation, and guesswork goes on with the other part you'll see very shortly. In the meantime, he asked the question, what's out there? Well, I'm going to find out, he said, by setting up an equation. Very quickly, the upper portion of it shows you n, the number of civilizations that exist that are capable of communicating. That's what he was interested in. Got to be the communication, not only the life, but the communication taking place. So the n number of those communicating civilizations equals the rate of star formation in our own galaxy per year times the frequency of planets around those stars times the number of Earth-like planets around those stars times the fraction of life that exists on those planets times the fraction of intelligent life that exists on the planets times the longevity, or rather, next will be the idea of communicating as well, the capability of communicating, and the longevity. And it winds up that if you calculate all these things together, if you can, you wind up with longevity, how long they last. That number should be approximately the same, actually the same as the number of communicating planets or civilizations that exist. That's his equation. Now, the first three are pretty well known. First three values in the equation, but the other four are not. So you can fudge that around any way you want, and as a result, they came up with the idea that ranges anywhere from about, say 1,000 to about 100 million civilizations capable of communicating. But don't forget, we're talking about their existence might be in other parts of the galaxy far away from us. It takes a while to communicate, because how do you communicate? We communicate now by sending up probes which travel at a certain speed. They don't even travel as fast as light. It takes a while to get to where they're going. But by the time it comes back, we might not be here. So we have that kind of situation to contend with, and also the idea of even sending out radio information, radio wave, radio signals, electromagnetic radiation. And that's what we do so far. Well, here's an example of a plaque that was placed on one of the probes that was sent out. They're Pioneer 10 and Pioneer 11. And you can see when it was sent out in 1973, 72 and 73. And the plaque contains images of how we are, in case someone somehow comes upon them in space. They could tell who we are, how we look, what kind of spacecraft it was shown here, where we're located, where those lines are showing 14 pulsars that are located in our galaxy that point to us. So if you spot the 14 pulsars, show them in a diagram, we're at the center of where the pulsars point in our galaxy. And at the bottom it shows where we are as the third planet from the sun in our solar system. So this plaque is both on Pioneer 10 and Pioneer 11. It was made up, it was organized and planned out by Frank Drake and Carl Sagan. Carl Sagan was an famous astronomer. He did the cosmos on TV, and you may know his name. He passed away quite some time ago. Now, this shows you a telescope which no longer exists. It collapsed in Arecibo, Puerto Rico, extensive telescope, a radio telescope, that sent out this message you see in the middle. The message is a radio message in code, binary code system, where if you kind of decode it, you come up with those blocks. Put the blocks, they're in a certain position of blocks, which make figures, and the figures are supposed to indicate who we are, how we look. You can see it there. DNA molecule is there. What planet we are in our solar system, and so forth. Almost to a certain extent like the plaque that was placed on the Pioneer 10 and 11 that was sent out into space. Now the message was aimed at a star cluster designated as M13 in Hercules constellation. Many stars in a star cluster, but the distance is about 25,000 light years away from us. So this was just a kind of a gesture, I suppose. It was to celebrate an updating of the Arecibo telescope as a kind of an exercise. But it's still going out there. So that message is still traveling in space. It'll take 25,000 years to get there. And then 25,000 years for them to send a message back if there's any planet with life that's capable of communicating going around one of those stars in the star cluster. Whoops. There we are. Now, this just shows you an example of how the radio wave is in a spectrum, electromagnetic spectrum of this type of energy, from low energy radio waves to high energy gamma radiation on the other side, where the waves are closer together. So the radio waves are like this, the width of a building, like this building here would be one radio wave. Right now, radio waves are going all over the place, bouncing off of everything. Got a radio, you can pick up the waves. Or a radio telescope, which we don't have. Now, in the meantime, the radio waves are being used as a means of communicating. Now, maybe it's not the only way. Maybe there's other ways of communicating which the civilizations that may exist elsewhere are communicating with, not using radio waves like we are. But we're using it because in this diagram it shows you information about why radio waves are used and why a certain kind of wavelength is used between 18 and 21 centimeters. In the middle, there's an area called the water hole, called that reason because of the fact that the radio waves are produced by hydrogen and produced by hydroxyl OH ions, HOH, water. So it's called a water hole because radio energy is being produced, as I mentioned, by the hydrogen atoms and by electrons, actually, in both of these, in the hydrogen atoms and in the hydroxyl, the OH. So it falls at a position between 18 and 21 centimeters, which is relatively free of noise because there's all kinds of other noise coming in. Noise from the Earth in terms of garage door operators, satellites traveling over, noise coming from other galaxies, noise coming from the Big Bang. So in order to avoid all that and get the quietest place to send out messages and even to look for messages, 18 to 21 centimeters in that range. The water hole. Got to go to the water hole. Whoops. I'll get rid of that. Yeah. Got to go back to what happened to zoom in. Oh, in the meantime, the idea being, that's good, yeah. The idea being that we also sent out these messages on other probes. Interesting probe. Voyager 1, Voyager 2. Anyone come across that information involving these probes in space now? Voyager 1 is at a point now beyond where, let me get it going here, beyond where the sun will influence that part of space called the heliosphere, where we have solar wind. Beyond the heliosphere is what's called interstellar space. The Voyager 1 now has gone out beyond the heliosphere is in interstellar space and is still sending information back to us. You'll like to check into that. Check NASA and the Voyager program. It's still operational. You'll get information from that. Also, on Voyager 1 and Voyager 2, they had placed gold records. And on the gold records, they recorded the sounds of our humanity in terms of music, human talking voices, music from the range of Chuck Berry to symphonic music. Also, sounds of nature as well. And also on the record itself, on the top of the record, is the information that they had placed on Pioneer 10 and Pioneer 11. Information about us once more. Now, there's a problem. Scientists are now saying, wait a minute, do we really want to send out these messages telling everybody out there where we are and who we are? I mean, if they're good, no problem. But if they're not, we have a problem. So in any case, they're thinking maybe it's better just to look for a radio message being sent out by other communicating civilizations rather than us send out the information. But it's too late. It's out already. It's out already. And don't forget, information is going out since we started radio programs. That's going out into space. That's gone out a certain distance so far. They'll be receiving our radio programs, the old ones first, of course. Jack Benny and so forth, if you remember that. I don't know. And TV programs will be going out. Milton Berle, so on. Now, here's something interesting. The WOW signal received by the Big Ear telescope. This received a signal, radio signal, in the 21 centimeter range, which was an outstanding one. It stood out among the other signals in that it was very strong, had a strong strength, and was powerful in all respects. It just popped out to the viewer. And they said, uh-oh, this looks like something that might be a signal coming from an intelligent civilization. And so they marked it. And the person who marked it, you can see, wow, he marked it. This is the actual sample of where the data he marked it on. This happened, you can see, in 1977 as well. But this signal, as it stands, has not been repeated. Another signal has, and I'll get to that shortly. By the way, because of all this going on, trying to find out if there's any intelligent life out there, communicating, we can communicate with, organization has been set up, Search for Extraterrestrial Intelligence, or SETI. If you notice, the S on SETI is backwards. The person who designed this figured, I'll make it a question mark, so to speak, because we don't know if there's life out there yet. So they make the S backwards for that reason in SETI. Now, there's another question that arises, and this was posed by this physicist, Enrico Fermi, called the Fermi paradox, in the sense of he asking, if there's so many billions of stars out there and so many billions of planets out there since the beginning of the formation of our galaxy, our universe, I should have said universe, since the formation of our universe, shouldn't there be some kind of evidence of a communicating civilization at this point? Where are they all? That was his question. That was called the Fermi paradox. Where are all these communicating civilizations? Now, here's something interesting recently that occurred in 2017. A telescope in Hawaii picked up this object passing through our solar system, the Pan-STARRS telescope there, or observatory in Hawaii. So they gave it a Hawaiian name, which translated means a scout or a messenger from afar, from outer space, I suppose, something of that nature. Because it didn't have the hallmarks of the usual kind of a natural object in the form of a meteor or comet or asteroid. Flat, shaped flat, slender, reddish color, smooth, and so it caught the eye of a lot of astronomers. And the project has been set up now, I think, at Harvard to look for more of these objects that might be coming through our solar systems as artifacts possibly from civilizations elsewhere. That's what they have in mind. Otherwise, they just wanted a grant to do some research. I don't know. Now, here's something recently that occurred too, as you can see in 2020. Interesting information. This happened while running the project, as you can see over here. Breakthrough Listen, radio astronomy, radio telescope, the Parkes telescope. The Parkes telescope located in Australia. And what it did is it picked up signals, which again were almost like the wow signals, coming from the closest star to us besides the sun, coming to us from Proxima Centauri, 4.7 or 4.2, a little less, light years away from us. And the signals looked like they were potentially intelligent signals. Now, Proxima Centauri is part of a star system, Alpha, Beta, and Proxima Centauri. Proxima Centauri is a red dwarf, but it has two planets around it. One of them is in the life zone, the echo zone, the habitable zone, where water can flow as a fluid around Proxima Centauri, the red dwarf. But there's problems with a planet going around a red dwarf star, which might not receive the same amount of energy that maybe we are receiving here from the G2 star like our sun. So there's questions about whether or not any kind of life can exist in that kind of condition, even though the planet might be in the habitable zone of a red dwarf. But interesting, tantalizing, that's what it is, teasing, wondering whether or not there is life there. Now, as I mentioned in the beginning, the Chinese have sent a probe up to Mars. They found water on the dunes on the surface of Mars. Now, more than likely, it's highly saline, much salt in it. That's what enables it to flow on the surface and not vaporize as quickly, I would imagine. But they claim that they found something involving water on the surface. More evidence about the possibility of life existing on Mars presently. Don't know. Also, we received, I'm sure you've seen this on news TV, where some of the naval flyers have picked up some kind of objects flying by, whizzing by their aircraft while they're flying themselves, and also darting into areas where there's water, like the oceans. And they've taken some images of them, and these things are still there, not knowing what they are. And by the way, they used to be called unidentified flying objects. Now, of course, they changed the name because it takes on a different connotation, I suppose. They're unidentified aerial phenomena. That's what it's called now. Now, what do you think? Is there anything existing out there? Well, what you can do, by the way, is you can take part in this exploration and research by getting involved with the SETI at home. Well, you can connect and have a screensaver with this information coming in from SETI, from their telescope, radio telescopes, with fresh data. And you could be a civilian scientist taking part in their project, trying to spot whether or not there's any kind of a wow signal coming in. So you might want to check this out if you're interested. Check out your computer. Go on this site, SETI at home. You could take part in this. We'll see how it is anyway, see what's taking place. Now, at this point, we don't know whether there's life existing. We do know there's life on Earth, though. And since life can only exist because of mothers, and tomorrow's Mother's Day, we'd like to extend to you our best wishes and our love for all the mothers here for Mother's Day tomorrow, and every place in the world, of course. If you're interested in signing up with ACNJ or any other club, step up here afterwards. It just came to an end. Or if you want to join our chapter of the National Space Society, see me. I'll get you going on that as well. No money involved, but you have to dig ditches. No, you have to dig ditches either. No, just get involved in a few activities that we have. That's all. Any questions? This is the end of my presentation, and thank you for attending. Appreciate that very much. And again, happy Mother's Day, mothers.
All right. Thank you so much, Carl. Thank you for everyone who has joined us here and online. So I noticed a few of you have snuck in while the presentation was going, so you did not get the safety briefing. I need to unfortunately review that before we get into our question and answer session. So when we go to leave here, we are using headlights because we do not like getting run over, and we greatly appreciate your effort in not running us over. If you need to use the bathroom, there is a porta potty near the back to my left, your right, and there is also a museum and gift shop area uh, through the red outline door, also to my left, your right. Out on the field, we have several shed-sized buildings with roll-off roofs where you will find observers with telescopes who are very much willing to answer all of your questions.
I'm leaving.
No, you can't run away yet, Carl, because we do actually have a number of questions.
Uh-oh, I'm in trouble.
Like I said before, unfortunately, I've been monitoring chat, so I'm a little night blind since I've been staring at a computer screen. So when I call for questions here, you're going to have to raise your hand and keep it raised. Maybe wave it around a little bit so I can find you in the dark. So you can speak your question in the microphone so our friends at home can hear it.
Where's our spotlight?
I don't want to shine light
I know.
directly into people's eyes. That's just mean. All right. So I'm going to start us off with the first online question. What do you think the likelihood that we will find sentient life out there, but not realize it is because it looks nothing like what we know?
I'll answer online. No. I think there's a high probability, somewhere between the range that I mentioned, that has been put forth on the basis of Drake's equation, which ranges between 1,000 and 100 million. That's a wide range, I know, but somewhere in between. And whether or not it's like us depends upon what molecule it's built upon, the carbon molecule or the silicon molecule, which seems to be the only two that might be adequate enough to provide some kind of structure for life.
So I also answered this online just because I found that question so interesting that I say it's probably pretty likely we're going to find some form of life out there, but it's going to be dependent on whether we recognize it is going to be dependent on likely who happens to make first contact, because we all know that friend who would not see something unless it slapped them in the face, and also what the science then looks like, because technology is ever expanding.
Like those rocks on Mars that I showed, right? Looking for rocks on Earth.
All right, so I see a question out there. So 1 second, let me not step on people.
Has anyone interpreted the wow signal? Because it was just random letters and numbers to like kind of guess what the meaning may have been behind that.
They looked at the strength as far as I know. I'm not a radio astronomer, but as far as I know from the information I've received, they interpreted it on the basis of the strength of the signal that they got. In whatever way they determine strengths of signals. but on the basis of the type of signal they received, they being radio astronomers interpreted those signals as being something different than prior signals and signals that followed it. And that's why they marked that area on it, indicating that it had the potential of being a signal sent by some kind of intelligent communicating civilization. That might be the case. And that's what the radio astronomers did.
Good question.
I hope that answers it to a certain extent.
Oh, getting all the
That's why
rough questions right off
That's why
the
the person who looked at it called it a wow. I'm sure that he was going through, all this data day by day, coming by. All of a sudden, wow, something must have popped out very, very noticeably to him in order to mark it. Wow. And I'm sure that was the case.
Right. So our next online question was, are we doing anything to mitigate contaminating other planets with life from Earth?
That seems to be a major question. And of course, we have the Star Trek Prime Directive that we don't interfere with what's going on in the way of what kind of society they have. on these exoplanets if life exists there and we're visiting. But insofar as the notion of contamination, that is a major problem, and they try to do as much as they can to eliminate all the different kinds of possibilities of contamination on the probes that they send out. Uh, of course, on a radio signal, there's no problem. So if we receive a radio signal and try to communicate back, well, in the sense of maybe receiving a signal from Proxima Centauri, it's 4.2 approximately light years away from us. So it takes that signal 4.2 years to get here, 4.2 years to go back. There's no contamination there.
I actually have a question to bounce off of that because you said there's no chance of contamination with using radio signals. And this is for a person who has more education in computer science than me. I will say I'm not very technology literate. Can you send a computer virus over radio signals and really mess up someone's day?
Intentionally, but unintentionally, I'm sure that measures are taken to make sure that that's not the case when they do send out the signals by radio, the radio signals that go out. So they're generating radio signals, not going over a computer out in space, but the actual signal, the radio signal itself. As I mentioned, right now we have all kinds of signals bouncing around in this room. I just got hit by one. Watch out.
Yeah, it was just a random thought
Yeah.
because technically a signal is, a stream of data, and there are many other forms to do streams of data.
Oh, hey, by the way.
And that's a tangent we don't need to get into tonight, but it
I
was
have to
just fun
mention
thoughts.
I have to mention something I forgot. There's consideration that maybe the aliens, if they do exist, are not utilizing the electromagnetic spectrum to send out radio waves as a means of communicating, but now we've been receiving laser beams from different parts of space which seem to have some kind of potential intelligence connected to them, and that SETI Institute is also involved in what they call optical SETI, looking not only at radio information coming in, signals, but also optical signals in the form of laser. And so they're looking at that as well. And then some other scientists recently have come up with the idea, well, maybe they're not even involved in electromagnetic spectrum in terms of laser light or radio waves, but maybe they're using gravity waves, which we discovered take place. Or maybe they're using neutrinos, which are all over the place. That's what they've suggested. So it may not be the only means of communication in terms of radio signals and any other part of the electromagnetic spectrum of energy, but could be other forms in a way of, as I mentioned, neutrinos or gravity waves.
All right.
We're not
And
tuned into that.
another question from our people out here. I hear a lot of crickets. I don't see a lot of hands. Remember, I'm night blind.
Well, let's get cricket then.
Well, when you have a question, just raise your hand and wave it about. I'll probably see it. So our next online question is, if more than one, and they didn't clarify, so I'm going to guess the Galilean, when we were talking about the Galilean moons of Jupiter, if more than one of them contains water, why specifically did they choose Europa to try and probe?
That's the first one they came across, and they were pretty sure that there was water on Europa. Now they realize, after some more probes have been sent up there, that there's water existing on at least the other three large Galilean moons. No, the two other ones involving Ganymede and Callisto, as well as Europa. But Europa was the first one that they came across initially in their probe, where they did spot the existence of ice on the crust, and they knew that.
So
And they have to pick
it was
one.
first come, first serve.
They
So
have
it's like,
And they have to pick one.
yeah, first one.
Heads or tails?
Perfect.
Hi. What's your favorite planet?
You
Oh,
knew I'm
that's a
going to
loaded
say
question.
this. You knew I'm going to say this. Earth. No. I like Mars. It has that mystery still surrounding it. It has all that information and evidence. Holy mackerel. Water underneath, water on top. Things that look like nanofossils. Oh, wow. So Mars is, I guess, one of my favorites in that sense.
All right. So our next question is, would the black hole in the center of our galaxy actually have weird effects on life the closer you are located to the black hole? Like, we're out in the boonies, so we don't care. What's it like in the city of the, the New York City of our galaxy?
It ain't nice. Well, that supermassive black hole is supermassive. It's a combination of a lot of other black holes that seem to coalesce like, I don't know, something that flows and coalesces. But it's supermassive, and a lot of the stars are being subsumed by that massive, supermassive black hole in the center. And something interesting, recently I came across an article, newspaper, where an astrophysicist has come up with the idea of testing for the possibility of a wormhole existing in the center of our galaxy in terms of somewhere in that supermassive black hole, which happens again to be located in the direction of Sagittarius. Sagittarius A is how it's designated. But notion being, anything nearby gets sucked into that black hole. Nobody knows what happens to it. What happens to the information? Does it leak out? Does it stay there? Maybe it's connected to another part of the universe where it comes out as a white hole. That's also suggested. Or maybe another part of time in the past. That's also suggested in the term of formation of wormholes along lines of connecting with the black holes. So there's all these kind of conjectures in terms of what these theoretical astrophysicists, say that 10 times fast, have in mind in terms of all these ideas.
Long story short, it sounds like the bleh, words.
Exoplanets?
Existential dread is a little bit more
Existential.
tangible near the center of the center of the galaxy than we experience.
Well, I'm sure that we're here today because we're in the suburbs of our galaxy. Oh, hey, something else. Something else. They're wondering why the orbits of the small and larger objects the size of Pluto, in which Pluto is located in the Kuiper Belt, it's called the Kuiper Belt beyond Neptune, or trans-Neptunian area of objects, called by that name as well. The orbital direction of these objects are pointed more or less in one direction. They're trying to figure out what's attracting these objects to have their orbits pointed in that certain direction. And one of the ideas is that we might have a small black hole located somewhere in that vicinity that's drawing on these objects. Could very well be. So there's all kinds of conjectures that are put forth, but still, it's good to have people thinking about these things because it leads on to other areas of exploration and searching for intelligent life possible in space. It's all part of the picture.
All right. Are there any questions out here? All right. So our next online question is, do you know what % of the exoplanets were discovered by citizen scientists and amateur astronomers?
Can't give you a precise number, I'm sorry. I don't know how many of the amateurs have found exoplanets. I'm sure there were more of the professionals, but still there are amateurs, I would imagine, that did locate them.
Because I know of at least a couple of our actual observer members who actually had worked on finding, helping work to
Yes,
find those
yes.
exoplanets.
But
So
it's hard to know everything, you know. And as a result, that's why they're coming up with artificial intelligence, which now is creating a problem, as you know.
sorry, I'm trying not to sneeze into the microphone. Allergies. Questions? Are you just waving your wand at me or just okay? Oh, no, one of my observer friends was helping direct traffic, and all I saw was the traffic wand waving, and I'm like, does he have a question or is he just mindlessly fiddling?
Actually, it's a magic wand. Watch out.
And again, I'm night blind, so I can see the motion, but I can't always tell if, like, is he trying to raise his hand? All right, so the next question is, do you know what they qualified communication as in that equation Because a lot of life on Earth communicates with other life. Or are they saying that it is only human-like communication?
Well, we're restricted by the idea, first of all, of what kind of means we're using to communicate and to receive communication. And as I mentioned, it was mostly in the past by electromagnetic radiation and energy in the form of radio. But as I mentioned, now they're opening it up to the optical area as well in electromagnetic radiation, and also possibly opening it up to maybe gravity waves, like I said, or neutrinos, and even other possibilities. But we don't know about these other areas. And for anything involving looking, searching for intelligent life that's capable of communicating, you need money. Without the money,
Don't
you
we
can't
all?
do it. And so they're restricted on that basis as well. So they're doing the best they can under the restrictions involving amount of money required to do that, and amounts they have, and what they have set up in the way of technology and instrumentation, radio telescopes, looking at those radio waves to find something else, which might be the case. I mean, you might have some of those civilizations communicating by different means that we're not even looking at right now. And so we're never going to receive their communication. That's a possibility, but we don't know that. We have to do one step at a time, and that's where we are today.
All right. So I'm going to put out a last call for questions online. If you have any last minute questions online, do get those in. And while they're getting those questions in, I do know I have two more questions already in the queue. Do you guys have any more questions? And remember, I'm like a T-Rex. I can't see you if you can't move.
Oh, come on, I'm getting hot.
All right. So the next online question, is there a plan to rebuild a telescope like Arecibo again?
As far as I know, there is not, because the Russians have introduced a telescope that's larger than that already. And we're planning to send up a kind of a series of telescopes, all connected, acting like one telescope. That seems to be the direction that we're headed in terms of any kind of research along those lines, where we can set up, like for example, recently, you've seen, I hope you've seen this, and if you haven't, please look at it on a computer, by all means. Image of the black hole, a black hole, first time imaged. It was imaged because of the fact that about 7 or 8 telescopes, radio telescopes, were connected by computer using a certain algorithm that was arranged by some kind of young woman. Bauman is her name. She got the algorithm that enabled them to connect 7 radio telescopes around the world from 7 different areas, acting as one large radio telescope. And this was a telescope that got the image, the radio image, which was then converted into an optical image by computer later on. But they got the image first of all, using interferometry, it's called, connecting a lot of instruments together working as one. Interferometry. The process, interferometer is the device, interferometry is the process. That's what's been done. So we don't need a telescope like the Arecibo anymore. We can use these measures, which I'm not sure, but I think might be less expensive.
Oh, I wasn't thinking about expense, but just like some people like myself who get new telescopes, just because you don't need a bigger, better, or newer telescope doesn't mean you don't want one. Anyhow, so
Go fund
our
me.
our our last online question that we have so far is, how long does it take for Voyager probes to relay data back to us now? I would imagine it's a lot longer than when it first started.
Well, let me think. The Voyager 1, I mentioned, is in interstellar space. And a radio message travels as fast as light. All electromagnetic energy from radio to gamma travels at the same speed as light, 186,000 miles per second. So if the Voyager 1 sending back data is out as far as oh, let's see. It's uh, 500 AUs, astronomical units, which means the distance between us and the sun, which is 93 million miles. Uh, it's on about 500 times 93 million. Uh, so it would take, let's see,
That's a lot of
total.
are we there yet's in the car with the kid.
It would take, I don't know, I'm guessing now. I would have to work this out. I'm guessing right now. My brain is not functioning. It turned to jello after a while. But it'll take about a day or something like that. Not long at all, because look, it's sending a message back in just beyond the heliosphere that it just left. So it's not even as far as Proxima Centauri, the nearest star to us besides the sun, which, as I mentioned, is 4.2 light years away. It takes 4.2 years being that far. Well, the message is being sent at the speed of light, but it's not going to take that long. So far. And I don't know what kind of information. I tried to find out. I went online. I'm going to try again. But I haven't been successful as to what kind of information it's been receiving from Voyager 1. Voyager 2 is still going out there as well, so it should be the second one going out there into interstellar space, radioing back the information. But that would be quite interesting. And I try to connect to JPL, who's in charge of the project, to find out what kind of data they're receiving now from the Voyager 1. But haven't been successful. Maybe you can try, if you're interested, finding out what kind of data the Voyager 1 is sending back right now.
That's actually a good thing. So if someone does find that out online, or anyone here, if you do find that out, go onto our Facebook page or into our Discord server, or even onto our stored YouTube video, and just drop that in that comment box and shoot us an email, because honestly, I'd love to know. And if you have connections to get answers from JPL, we got to talk. Right.
Hey, call me up too. I want to find out.
Shh, they're my source of information. I
Uh-oh.
want all the gossip. Anyhow, any
get
last
even.
minute
I'll get even.
questions? Bueller?
Any answers?
Bueller?
You didn't ask that. Come on,
42.
any answers?
42 is definitely the answer. Life, the universe, and everything. That being said, I want to thank you all for coming out, and for everyone who's come here on site, and both visit us online. With that, we're going to wrap it up for tonight. So everyone have a good night. And like I said, do check us out on our website, uacnj.org, and our social media, including our Facebook. We'd love to see you there. Until next time, bye.
Don't forget, you want to join up. Step up here. Join up to one of the organizations. Come on, get involved.